Ever wonder how the smartest companies seem to make all the right moves in a world that's just flooded with information? Well, it's because they speak a certain language. And that's exactly what we're going to get into here, the language of data and statistics. Okay, let's dive in. You know that feeling of just information overload? It's kind of like looking at a jumble of random, chaotic dots. Well, statistics is the tool that lets us cut through all of that noise. It helps us find the pattern hiding in plain sight and turn it into a clear signal you can actually use. It's all about finding that one single meaningful line in a whole mess of data. And look, this is not just some theory from a textbook. This is an absolute business necessity. Think about it. Accounting uses sampling to check their books. Finance relies on stats like PE ratios to make investment calls. Marketing uses scanner data to figure out the perfect price for a product. Every single part of a business uses statistics to handle uncertainty and, make smarter decisions.
All right, so if this is the language of business, we've got to start with the basics, right? So first up, let's break down the anatomy of our raw material, the data itself.
This table here makes a pretty complex idea really simple. First, you've got your elements. That's just who or what you're studying. In this case, it's companies like Abbott Labs. Then you have the variables. These are the things you care about, like the stock price or earnings per share. And an observation? Well, that's just one single row that has all the info for one element. That's it. That's the basic structure for any data set you'll ever see. Now, pretty much all data boils down to two main flavors. On one hand, you have qualitative or categorical data. Think of these as labels or categories, like which stock exchange a company is on, NYSE or NASDAQ. Then you have quantitative data, which is all about numbers. It tells you how much or how many, like a company's earnings per share. And knowing which is super important because it determines the kind of math you can do later on. Here's another pro tip. Not all numbers are created equal. Data actually lives on this kind of hierarchy, like a staircase of precision. Way down at the bottom, you have nominal data. Those are just simple labels. A step up is ordinal, where the order matters, like a good, better, best rating. Then there's interval, which has set units but no real 0 point. And at the very top, the most powerful, is ratio data. It has a true zero, which lets you make really strong comparisons, like this stock costs twice as much as that one. The higher you climb these stairs, the more powerful your analysis can be. So you've got your data, you know what kind it is, you're ready to go, right? Well, hang on a second. Before you do anything else, you have to ask yourself one absolutely critical question. Can you actually trust this data? This is so important because just blindly running with the data you're given is a recipe for disaster. A tiny little transposition error, typing 24 instead of 42, can wreck your results. Or what if someone misunderstood a survey question? Things like this, plus weird outliers, create bad data that just doesn't reflect reality. So here's the bottom line. You must review your data for accuracy before you even think about starting your analysis. Okay, so now we've got clean data we can actually trust. What's next? Well, now we get to the fun part. We get to take that raw information and start summarizing it to find the hidden patterns. And this is the world of descriptive statistics. This right here is the magic of it all. We start with these messy, raw data files. The first thing we do is organize them, maybe into a nice, clean table. From there, we can turn it into a visual, like a graph. And finally, we can boil all of that complexity down to one single powerful number, like the average earnings per share. We've literally gone from a pile of numbers to a clear insight. And seeing your data is key. For our qualitative, categorical stuff, like the stock exchange, a simple bar graph is perfect. You can see in a second that most of the companies in our list are on the NYSE. And for the quantitative, numeric data, like share price, a histogram is your best friend. It shows you the distribution, how the companies cluster together at different price points. These charts let you see the whole story in the blink of an eye. All right, now we're getting to the most powerful idea in all of statistics. So far, everything we've done has been about describing the data we have. But what if we could use a small piece of data to understand a much, much bigger picture? Well, that is the incredible power of statistical inference. The big idea here is the difference between a population and a sample. The population, that's the whole shebang. It's everyone or everything you're interested in studying. The sample is just a small, manageable piece of that population. So why do we do this? Well, because trying to measure the entire population, what's called a census, is usually way too expensive, takes forever, or sometimes it's just flat out impossible. Let's make this super clear with an example. Say you work for Norris Electronics, and you need to figure out the average lifespan of your new light bulb. But here's the catch. The only way to test a bulb's life is to let it burn until it dies, right? It's a destructive test. If you tested your entire population of light bulbs, you'd have zero left to sell. A census just isn't an option.
So what do? It's brilliant, really. You use inference. You take a sample, let's say 200 bulbs. You test them, and you find that their average lifetime is 76 hours. That's your sample data. From that one number, you make an inference. You estimate that the average lifetime for all the bulbs you produce is also right around 76 hours. You've just used a tiny bit of information to understand the whole. That's a huge leap. So we have these amazing concepts, these powerful tools, but you might be thinking, hey, with computers that can do all this math in a split second, what's my role in all this? And that is a fantastic question. This brings us to what we call the analyst's edge.
This is maybe the most important takeaway of all. Software, Excel or whatever you use, is amazing at computation, at crunching the numbers. But that's not where the real value is anymore. The analyst's edge, your edge, comes from the human element. It's making sure the data is good in the first place, and way more importantly, it's providing the strategic interpretation of what those numbers actually mean. The machine can spit out an answer. Only you can provide the meaning.
And really, it all comes down to this. The data, the software, the computers, they will always be able to tell you what happened. But they can never tell you why it happened, or what you should do about it next. That takes curiosity. It takes context. It takes critical thinking. That part takes you.